Blockchain technology has long raised concerns about its environmental impact, especially with proof-of-work systems like Bitcoin and Ethereum, which consumed a lot of energy. Ethereum is now shifting to a more energy-efficient method called proof-of-stake, reducing the industry's energy consumption. However, achieving both decentralization and sustainability is a challenge. Blockchains are exploring techniques like sharding and rollups to scale up while using less energy, but these solutions add complexity. Interpretation of sustainability reports must be done cautiously. In contrast, the Internet computer ecosystem has introduced a sustainability policy. The question is, has it found the balance between scalability and eco-friendliness? A report titled Internet Computer Footprint, IC Sustainability Report 2022 provided some insightful numbers to that very same question. How is carbon footprint calculated? The Internet Computer Network is made up of nodes located in data centers all around the world. Now, these nodes use electricity from regional grids to perform computations. There are 518 active nodes and 208 standby nodes in the network. Each active node consumes around 0.002 kilowatts of energy. Now, you can see here how many kilowatt-hour active nodes consume compared to active and standby nodes. The network's average emissions factor is 0.262 kilograms per kilowatt-hour, meaning it produces around 0.262 kilograms of carbon dioxide for every kilowatt-hour of electricity. You can see right here how many metric tons of carbon dioxide active nodes consume compared to active and standby nodes. Now, a graph illustrates the total emissions from active nodes, ranging from 113.9 to 480.56 metric tons of carbon dioxide equivalent per year. This helps assess the network's environmental impact and efficiency. Now, please note that there are differences in the estimates between the table and the emissions graph, possibly due to different assumptions or calculation methods. Comparison between IC network and traditional web hosting services. In summary, the Internet Computer Network stands out as a more sustainable and efficient alternative to traditional web hosting services like Google Cloud, Amazon Web Services, or Microsoft Azure. And these traditional services heavily rely on centralized servers powered by fossil fuels, contributing to greenhouse gas emissions and climate change. In contrast, the IC network employs a decentralized node network using various energy resources and achieves a higher clean index energy of 72%. Moreover, the IC network utilizes chain key technology, a novel consensus protocol that minimizes energy-intensive computations and validations among nodes. This not only saves energy, but also allows users to host their websites and applications on nearby nodes, reducing latency, bandwidth consumption, and the network's carbon footprint. In conclusion, the IC network's sustainable approach involves lower energy consumption, reduced carbon emissions, and the support for renewable energy-powered web hosting, promoting a greener and more eco-friendly web ecosystem. Looking ahead, the IC's carbon footprint. The Internet Computer currently operates with 518 active nodes and approximately 700 standby nodes. By the end of 2022, it aims to expand to over 1,000 nodes, with around 30% in standby. If this projection holds, estimated carbon emissions for the IC could grow to a range of 218 to 981 metric tons of carbon dioxide equivalent per year, considering each node emits between 0.2 and 0.9 metric tons of carbon dioxide equivalent per year. Looking ahead, a tenfold expansion to 10,000 nodes could result in emissions ranging from 2,224 to 9,387 metric tons of carbon dioxide equivalent per year, equivalent to the emissions of over 1,900 US homes. This underscores the connection between blockchain scaling and increased carbon emissions. Promoting sustainability within the IC makes business sense, as climate-focused startups are more likely to choose it as a partner if it sets an example of sustainability. Consumers and employees increasingly prioritize environmental concerns, fostering a culture of sustainability within the IC, which benefits both its ecosystem and the planet. It also prepares the network for expected regulatory changes as climate goals gain urgency in the coming decade. This video provides a snapshot of IC's sustainable efforts, marking the first step towards reducing its environmental impact and setting an example for other blockchains. Stay tuned for our next video, where we explore more aspects of ICP.